Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. Today's topic is about learning various aspects of Proc SQL using a case study. To understand this case study, we need to look into a couple of data sets. And these data sets are known as debit and credit. These two data sets belong to a fictitious bank, and these data sets have three variables each, and one variable cust underscore id is common for both the data sets. And for the debit data set, we have two other variables, which is money underscore deposit, deposit underscore date. Whereas in the case of credit, the two variables are money underscore credit, credit underscore date. Now that we have briefly looked into these variables of this data set, now let's have a quick look on the data itself. The data, if you can see, has a cust ID which has multiple deposits. In the case of debit, credit also has multiple transactions of credit per each customer, and cust ID represents a customer. Now let us quickly look into how we are going to frame our questions based on these two data sets. Based on these two data sets, we want to solve few problems. Before going into those details of what problems we want to solve, I would like to tell why we want to solve these problems. Say a company has a credit card and debit card business. So why does it wants to know more details? For example, a person has a debit card but he does not have a credit card. So company would like to offer a credit card to that person. And there are many things in which the bank wants to do extra business. So we have some problems to solve so that this particular bank can do it better. What are the questions we want to solve? The first question we want to solve is we want to find customers who are in credit table but not in debit table, and vice versa. And we also want to know customers who are in both the tables. And finally, we want to know customers who have more debit than credit, and vice versa. To solve all of these problems, we will be using various aspects of Proc SQL, and that is what is all about this presentation. Now let us discuss how to solve the first problem, that is finding cust underscore id from debit table which is not in the credit table. How we can solve this problem? This problem can be solved with the help of this piece of code. Regarding this piece of code, I will be discussing in much detail in the next slide, but for now I will very briefly explain what is happening. So what I want is I want to find cust ID from debit table which is not there in credit table. If we clearly think about this problem and try to write the code, it is pretty much in the plain English we can write this answer. Here we are writing, hey, please give me cust ID from debit table where cust ID is not there in the credit table. And in the credit table, we have put this in the bracket. And we get the answer of cust ID with the value of 2. Cust ID 2 is there in the debit table but is not there in the credit table. Now, as you have seen that we have multiple instances of cust underscore id 2, we need to use distinct to get the just one unique row for this particular cust id. So distinct helps us to give a unique row for us. Now let us try to understand this code itself, what is happening here and what is this known as. If we see closely in this particular code, there are two selects. The first select is known as outer query. The second select, which is in the parenthesis, is known as inner query. For this particular query, the inner query runs first and gives the result, something like below. And then the outer query runs and it gives the final output we want. This kind of code wherein we have two selects is known as subquery. And in subquery, most of the instance we have a where clause in the outer query, and then we are doing some kind of comparison with inner query. Moreover, this kind of subquery is known as non-correlated subquery. The reason why this code is known as non-correlated subquery is as follows. In this particular style of code, inner code always runs separately and it gives a result, and then a comparison happens with the select query which runs as an outer query. So the important point to know here is, if I remove this inner query and put some numbers like in here, this code would still work. What does this tell us? This tells us that the innermost query is not dependent on outermost query and it can run on its own. That is why this code is known as non-correlated subquery. And there is also a concept of correlated subquery wherein inner query and outer query are dependent on each other. I just can't write an separate bracket and then write whatever I want to and get the result. Both the queries dependent on each other, means they are correlated to each other. Unlike what we see here, where just inner query runs first and gives a result and then outer query works. For this presentation, I will be not discussing anything about correlated subquery. In the very beginning of this presentation, we discussed one more scenario, that is where we have cust IDs which are in credit table but they are not in the debit table. Doing this is very simple. The code is pretty much same. The only change we need to do is, in the outer query, instead of debit, we need to write credit. Instead of writing credit in the inner query, we need to write debit. That will give us cust IDs which are there in the credit table but not in the debit table. Now let us move further. To finding common cust IDs, it is pretty simple and straightforward. What we need to do is, we need to change not in the earlier code which we have seen to in. Now we are having pretty much the same code, but what we are trying to do is, we are trying to find the in, means the cust IDs which are there in both the tables. Now let us look into the next topic. Our next topic is to find customers who have more debit than credit and vice versa. To understand this problem, let's look into our data once again. We have debit and credit tables. Both of these tables have detailed data. What does detailed data means? You have individual transactions rather than summarized value. And to solve this problem, first what we need to do is, we need to aggregate values by group. What does that mean? If I have to compare ID 1 in debit table with ID 1 in credit table, what I need to do is, I need to sum up by ID. And here, once I sum up for ID 1, I also need to sum up for ID 1 here in credit table. To do this sum, what we need to do is, we need to use aggregate function along with the group by for each data set. Once we have done aggregation per each group, next what we have to do is we have to compare each cust ID, which means we have to bring the data together. For that, we need to join the tables and then do the difference. Now let us look into how we are going to do each of these steps. First, let's look into how to do aggregate function with group by. I have made a detailed video on aggregate functions, and the link for that particular video I will give in the description below. Now let us quickly look in what we are doing in here. Here I am using select cust ID and then I am summing up money underscore deposit from debit table. And you can also see that I am doing group by cust ID. Basically what this particular piece of code does is for each cust ID it will sum up the money which is deposited, and I'm naming that new column as sum underscore of underscore deposit. And also after doing this I'm using a create table statement wherein I'm creating a new table that is known as debit underscore sum. By doing this, I am able to get the total for each cust ID in the debit table. Similarly, I will do the same for credit table, wherein again I am doing sum for each cust ID by each group, and also I am creating table which is known as credit underscore sum. In here I am doing sum on money underscore credit variable, and the value which we get I am naming that as a new column or variable which is known as sum underscore of underscore credit. Now that if you have seen both the queries, we are able to get total for each cust ID and they are in two different tables. Now to bring them together, all we need to do is a join. And I only want to compare those cust IDs which are there in table 1 and also which are there in table 2. For purpose of this particular example, cust ID 1 and 4 are there in both the tables. Whenever we want to find the common cust IDs or any ID or any column on which we are joining, all we need to do is we need to use an inner join. This gives common cust IDs for both the tables. Now let us see how we can do this. Here I am inner joining debit underscore sum table with credit underscore sum table. And then here I am using A as alias for debit underscore sum, B as alias for credit underscore sum. And then I am doing on condition wherein I am joining on A.custid equal to B.custid. And in here we are bringing sum underscore deposit and sum underscore credit, both the variables, into our queries. And also I'm also bringing the cust ID. It does not matter whether I bring cust ID from debit underscore sum table or credit underscore sum table. But the important point here is I need to mention from which table it is coming. The reason for this error is because this code will not understand whether the cust underscore ID is from debit underscore sum table or credit underscore sum table. And for our purpose, I am just mentioning as A.cust underscore ID. It does not really matter what we try to give it here. A.cust ID or B.cust ID, whatever it is, it works. And then as we have sum of deposit and sum of credit variables, what I am doing is I am comparing both of them in my case when statement. How to write case when statements, I have made a video on this, and the links for the same I will give in the description below. And in this case when statement, what I am doing is when sum of deposit minus sum of credit is greater than 0, I am saying that it has more deposit. And when sum of deposit minus sum of credit is less than 0, then I am saying it is more credit. And when sum of deposit is equal to sum of credit, then I am saying that they are equal. And these are self-explanatory. If sum of deposit is more, then there will be more deposit. Means the value here will be greater than 0. And let's quickly look into the result. Here I have cust ID 1, sum of deposit is 8,500, sum of credit is 2,000, and then when we do minus of this, we have more deposit, and here you can see we have more deposit because the value is greater than 0. Whereas in the case of cust ID underscore 4, our sum of deposit is 1700, and when I do minus 3700, it will go to minus 2000, and it is more credit. And I do not have any values in which the sum of deposit equal to sum of credit. From here, you can see that by doing aggregations and joining tables, we were able to bring both the tables together, and we were able to compare, and we were able to also find which cust underscore IDs have more deposits or more credits. This we have done in various steps. First we have done aggregations, and then we have done joins. But we need not do this way. That means we need not do this in 2 steps, but we can do all of this in 1 step. That is what is going to be discussed in coming 2 slides. Now let us quickly focus on the code which I am showing in here, which we have used earlier to get our results. If you see here, we are using debit underscore sum dataset or table, credit underscore sum dataset or table. But if we closely look into debit underscore sum, it was created with the create table statement code as follows. And credit underscore sum has been created in the code as shown in here. In reality, and in the most of the cases, we need not create tables, but we can use the same code what we have used in here instead of dataset name here. And also we can do the same, that we can replace this credit underscore sum by the code here. Now let us see how we can do. And also, before going into any more details, I would like to say that this kind of concept is known as derived table or inline view. In some databases and other places, they use this concept as derived table, and some call it as inline view. And both the names are fine. Now let us see how this is going to be done. Now if you see, instead of the table, we have just kept the code in here. That is, instead of debit underscore sum table, we have the code which creates a debit underscore sum table. And also the same is for credit underscore sum. We have replaced it with the code. As I said to you earlier, this concept is known as derived table. What happens is, this code runs, and this piece of code also runs and creates the data we need, and this is kept in memory, and then the inner join happens, and we are going to pick up the results from here by using our from clause. And here I want to tell you one quick thing. Whenever we use a derived table or inline view, most of the time what we do is we use a from, so that whatever happens here, we are going to pick up the data from here. And then we can do whatever the manipulation we want to do. Here we are using case statement, and we are manipulating our results to find whether our sum of deposit is greater or our sum of credit is greater, and then we are able to create a new variable also. In this whole presentation, we have looked into quite a few topics. The first one being subquery. Then we have looked into aggregate tables, and then also we have looked into inner join followed by a derived table. And by using all these concepts, we were able to solve a business problem. It is always very important to know these concepts so that you can apply to any other business problem. That's all for this topic. If you have liked this topic, please give it a thumbs up, share and subscribe. Thank you.